Okay, so hi everyone, welcome to my session on Scylla Summit 2023. Use ScyllaDB to replace Amazon DynamoDB everywhere, better, more affordable, all at once. And I hope to keep up to this premise. I'm Zach Leviatan, VP Product at ScyllaDB. Before that, I spent many years in the telecom domain. And as you might see, the picture here is from a few years ago. And I'm getting older from summit to summit. So what is the agenda for today? Three main parts. I'm going to compare Amazon DynamoDB to ScyllaDB. I'm going to explain what is ScyllaDB Alternator, a DynamoDB compatible API. And if you are convinced that ScyllaDB is a good alternative for you, I'm going to explain how to migrate from DynamoDB to ScyllaDB. Spoiler alert, this is a summary of what I'm going to show. So ScyllaDB is compatible with DynamoDB, but can run on more platform. ScyllaDB is less expensive than DynamoDB and have lower tail latency. In particular, we're going to talk about P99 latency. And you can migrate from Amazon DB to ScyllaDB without downtime. So now it's up for me to prove each of these points. And let's start with comparing DynamoDB to ScyllaDB. And we are doing that with benchmark. So I'm going to spend a minute or two explaining the setup of the benchmark. I want to say that benchmark is not trivial, although we have a lot of experience with it. In the last few years, every time we do a new benchmark, we find new issues. And I will explain in a minute why it's problematic. But just the setup that we chose for this demo, we're using a standard benchmark tool called YCSB, originally from Yahoo, but now it's like a standard for NoSQL databases. We're using the latest and greatest Scylla Enterprise version, 2022.2. The Scylla cluster that we are comparing Dynamo to is pretty small, 3 nodes of I4I 2 extra large. So you can imagine that if we use 8 extra large or bigger, we can push much more traffic. We do use 3 different zones. That's the default on Scylla Cloud. Of course, it has advantages and disadvantages. It's very reliable because if one of the zones is down from some reason, you can still have a quorum, but you pay for it to some extent in latency because there is a cost of moving between the zone. As you will see very soon, the P99 is still very, very low. We're using C5 for the loaders. Not a lot of storage here because we mainly want to test latency, so it's 1 terabyte. And we're using different distribution of data. I'm going to touch on that later. Why testing is sometimes problematic and why in some cases we found that customers that try to do benchmark fail or not fail, get the wrong result, I would say. First, there's many combinations. You can choose the number of loader, thread, connection. You can choose a distribution, Zipfian or Uniform or whatever. You want to build your test in a way that you can reproduce and get reproducible results, similar result every time. You need to understand the loader, the benchmark tool and its problem or advantages. Does it suffer from coordinate omission or not, etc. And you need to understand the database that you are testing. Even though DynamoDB, it's a black box for us, we don't know exactly how it's implemented. We did find out, for example, that it failed or not failed, doesn't behave nicely with Zipfian distribution. We need to understand why and maybe switch to other distribution. So without further ado, let's jump to some result. So this is a result that we got from the Scylla cluster that I mentioned earlier, of 3 nodes. The cost, by the way, of such a cluster for a year is around $30,000, which is not much. Spoiler alert, when we're going to see a DynamoDB cost for a similar throughput. We tested here with hotspot distribution. Hotspot distribution try to mimic a realistic use case when you have a lot of partition, but only a portion of them is busy at every time, or all of them are busy, but the hotspot, as it's called, is more busy than the others. And we tested with different ratios of read versus write. So for example, the first row here represent update of 10% and reads of 90%. etc. till update of 90% or read of 1%. And you see here the throughput that we can push or utilize Scylla cluster in this case, and the P99 latency. In this entire presentation, I'm only going to show P99 latency because it's more relevant and more interesting in most cases than the mean latency. As you can see, even this small cluster can handle around 100,000 requests per second with a P99 latency of 1 digit, which is really impressive. The mean latency, by the way, will be sub-millisecond in most of these cases. You note that Scylla is actually better in write-intensive workload than in read-intensive workload. That's come from the design inherited from Cassandra and the Dynamo paper, by the way. But even for read-intensive, the throughput is still very high and latency is still very low. So quite an impressive result. One thing I want to mention that when you're doing benchmark, you usually don't want to test maximum throughput and latency at the same time. So what we did here is first we measure the maximum throughput we can push to Scylla using the loaders. And then for latency and all the result that you see here, we use only 70% of this throughput, which is sustainable and have reasonable latency. If you push any system, not just database, to the max throughput, you get bad latency. That's a fact. This is the same data visualized in a way. I hope it make it clearer and not more complex. This graph show both the P99 latency in colors, and in blue it show the throughput that we push for every use case. But the data is the same, so let's not spend too much time on it and compare it to DynamoDB as promised. So with DynamoDB, again, we tested with hotspot, the same hotspot distribution, the same loader, and a different ratio of updates and reads. And as you can see here, and let's focus right now, let's ignore the throughput for a minute and focus on the latency. As you can see here, the P99 latency is much higher. So if with Scylla it was below 10 milliseconds for all use cases, here it's above 20 for this distribution. With other distribution, it's even worse. By the way, the X here means that this you have 0 read, so there is no read latency. The same visualization for DynamoDB. By the way, you might notice that DynamoDB is actually prefer reads, or the more intensive the read part of the workload, the better DynamoDB behave, which is the opposite of Scylla. So each of these databases have a different sweet spot. Just touching on the cost, if you remember earlier, this throughput of around 100,000 or more was around $30,000. Here, roughly the same scale of throughput cost much, much more, and it can be up to $500,000, which is a lot, of course. And later I will compare them head to head on the cost. And this is a later. So in this case, I try to compare the same throughput for Scylla and DynamoDB for one use case, a use case of a hotspot distribution with 50% read, 50% write. So the latency as before is better with Scylla. Here I actually do show mean latency, which I promise not to show. But you can see that the P99 is much better in Scylla, much worse in DynamoDB. But even more significant, the yearly cost of SilaDB Cloud compared to DynamoDB is about 10%. So you are spending 10 times less with SilaDB and getting lower latency in the same time. By the way, all the costs that I'm showing here is yearly with reserved, both in DynamoDB and in Scylla. Of course, if you commit 1 year, you get better cost or better prices, and that's true for most systems, including SilaDB Cloud and DynamoDB. I want to quickly touch on other distribution. I mentioned earlier that we use hotspot because we think it's more realistic, but we also tested with Uniform and Zipfian. Zipfian proved to be very bad for DynamoDB, and the reason is that Zipfian tend to send a lot of traffic to 1 or 2 partition, and this partition quickly become overloaded, and DynamoDB will throttle them, and the latency will be bad. So if your data isn't Zipfian model and you're using DynamoDB, I would strongly recommend you to improve your data modeling, because it simply won't work. It's not great for Scylla as well, by the way, but on DynamoDB it's really bad. So this is the same information comparing the different distribution just on DynamoDB. In the essence of time, I want to skip that. The full result of what we did on DynamoDB, I'm only showing it, so if you download the slide later, you know you have the information. So why some of your workload on DynamoDB, specifically we saw that on Zipfian might fail. DynamoDB have a hard limit for throughput per partition, which Scylla do not have. And this throughput, if you cross it for one partition, not only that DynamoDB will throttle you and start throwing requests away, worse, it will introduce latency, because this timeout take a long time. And basically all the requests that come after have latency as well. And you are in a very bad shape. And Alex Debris, by the way, and I hope I pronounced the name right, wrote a very good blog post about it. I recommend you reading it and everything he write about DynamoDB. Very interesting. So just keep in mind, if you're a DynamoDB user, that you might, if you hit this limit, you have a problem, and you probably need either to switch to Scylla or maybe improve your data modeling. So DynamoDB actually have two kinds of price model that I quickly want to talk about. One is on demand and one is provisioned. As with any system, and I mentioned it before, on demand is cost more. So on most use cases, if you know your workload in advance, and I think if you have a big system, you should, reserve capacity or provision will be much cheaper, and you mostly want to use that. But then you have another problem. What provision capacity should I set for each table? And let me give you a concrete example. It's kind of synthetic, but I think it's also typical. Let's imagine that you have 9 tables, and the sustainable capacity that you want for each is 20,000, 20K capacity. So this line here on the top represents the capacity you might want to provision. But unfortunately, the real life use case that you have, that each of these tables can peak to 100,000 requests per second. And it can be for an hour, 2 hours per month or per day. It's hard to predict. And now you have a problem. In DynamoDB at least. You have two main options. One option that you can buy or order reserve capacity for 100K for all of these tables. This makes sense. It will fix your provisioning problem, but of course will cost a lot of money. And if you fall from provision to on-demand, it also costs. So you don't have a good solution here. One solution that people use sometimes is to actually use one huge table for all of this table. It can work, but have other data modeling problems that I'm not going to touch on. I would recommend using this method of single table design only if you have the same partition key. On Scylla, you don't have this limitation per table. So if you allocate an additional capacity for all the cluster, which doesn't have to be huge, if one of these tables peak and the other are not at the same time, you're still inside your cluster capacity. Like in this case, so in Scylla, for example, if I allocate or size my cluster for 250,000 requests per second, it can sustain one or two table peak, and the cost on Scylla Cloud will be way less than DynamoDB. In this case, more than 20 times less expensive than DynamoDB, because you don't have to understand or provision the capacity per table in advance. You can do it for the entire database. So that's much easier. I hope by now you're convinced that ScyllaDB costs less than Dynamo and have better tail latency. So I want to switch to another topic, ScyllaDB Alternator. What is ScyllaDB Alternator? So some of you which are familiar with ScyllaDB for many years know that we started with Apache Cassandra compatibility. But around 4 years ago, we introduced DynamoDB compatible API as well. We call it internally, we call it Alternator. It's based on REST and HTTP, not on binary protocol. Why using Alternator? So let's say that you're using DynamoDB and you want to switch to Scylla. So you can, in theory, update your application and start using SQL driver and work with Scylla, but it's easier for you just to change the IP on your application and working with the DynamoDB compatible API. Another alternative that you might want to migrate from DynamoDB to on-prem, GCP, AWS Outpost, or any other platform that does not have DynamoDB there, or maybe you don't want to pay the cross-cloud cost of working from on-prem to AWS. So ScyllaDB with Alternator is a good alternative for you. So ScyllaDB, as I mentioned, is with us for 4 years now. It's production ready. It's available on Scylla Cloud, as I will demonstrate in a second or a minute. And we have production customer for it for quite some time, and more are coming every day. This is a typical use case, or not a typical use case. This is maybe a use case of one of our customers that run DynamoDB API on production, the Alternator on production. So we have 80 nodes. I wouldn't disclose the name, but you have 80 nodes and 400,000 requests per second. The estimated cost here is much cheaper for ScyllaDB as expected, but to be completely transparent, I don't really have the number how much they are paying to AWS. So this is like an estimation using the AWS calculator based on the request per second and storage that they have. So as you can see, again here, even with Alternator API, Scylla is much more, makes sense from price perspective. Okay, so let's do a quick demo. And now I have to switch tab, I hope. Okay, so we talked about Alternator in the cloud. So you're probably asking yourself, what is Scylla Cloud? So this is Scylla Cloud. It's a SaaS application that runs Scylla Enterprise as a managed service. You can run, let me demonstrate a new cluster here. We have dedicated and serverless in beta. We have a full session about serverless on the summits. I'm going to ignore it, at least for now. If I'm going to dedicated VM, I can choose AWS or GCP, and more importantly, I can choose if I want a SQL API or DynamoDB API. I already have a cluster running. It's actually running from my own account on my own credit card, so I'm not going to start another cluster. You note that I did choose T3 Micro, which is a very small instance, only used for evaluation, so the cost will be low. If I'm going to the cluster information, I see here connect instruction, so I can copy paste it to my terminal. I'm not going to demo all the connection here. You can do it yourself. I just want to mention that this example was directly copied from DynamoDB example. And if you are familiar with DynamoDB, you will see everything is exactly the same. The only different parameter here is the endpoint, which is different between the real DynamoDB and a DynamoDB compatible Scylla cluster. One thing I do want to show that if I'm clicking the monitoring page, I'm switching to this page. It's a Grafana dashboard, the standard Grafana dashboard for people familiar with Scylla. In this case, it's the Alternator dashboard. We have multiple dashboards, and here you can see the traffic going to the cluster. Of course, this is a dummy instance. I don't have any real traffic, or it's very, very low just from health checks and such. So not much to see here. Just want to quickly demonstrate the monitoring dashboard. And let's go back to Scylla Cloud. We have instruction of connecting with Python, other driver, etc. And I can take standard action on the cluster, like asking to scale it, delete it, etc. Keep in mind, and this is something that failed me in the past, that you need your IP on the allow IP list if you're doing such a demo. Most production cluster, by the way, does not use public IP at all. They use a VPC and do VPC peering between the application and the cluster. So with that, I hope you are now convinced that Alternator can run in Scylla Cloud and it's compatible compatible with ScyllaDB, with DynamoDB. This is the instruction. You can browse it offline and use it. By the way, it's very easy to evaluate Alternator or the Dynamo API with Docker. So I know that Dynamo also provided Docker for the DynamoDB, but to be honest, I think our version, the ScyllaDB version of DynamoDB, it's more compatible with the actual DynamoDB than the Docker version that the AWS provides. So if you want to run DynamoDB locally or on GCP, of course, another platform, Scylla is a good option. So what is the state of the API compatibility? We already support for many years. We support all the main operation like table operation, batch operation, item operation, query, scan, indexes. Time to live is a pretty new feature that we added this year, and all the standard data types. But some feature on DynamoDB are still missing, and we plan to implement them. And by the way, I will be happy to get the input of people on this session, maybe later on the chat, to let me know what is more important for you on our DynamoDB implementation. So we are planning to add point-in-time backup, export and import from S3, and in the future, probably not this year, paper operation and multi-item transaction, maybe in 2024. Okay, last thing I want to touch on is migrating from DynamoDB to Scylla. So you're already convinced that Scylla is less expensive, have better latency, and it's compatible with DynamoDB, but you already have a lot of information on DynamoDB. Now you want to move to Scylla. How to do that without downtime? So first of all, I assume here on this schema that you have a service that you cannot take down. You cannot sustain downtime. And you also have historical data that you want to migrate from DynamoDB to Scylla. If that's not the case, and you don't have historical data and you can sustain a few seconds or a few minute downtime, you can simply change the IP in our application from DynamoDB to Scylla and it will just work, as I will demonstrate earlier. But let's say it's not the case. So what you want to do, you're leveraging a DynamoDB feature that calls stream, which record every update that you do. You enable it on the table you want to migrate. And once you do that, you listen using a tool I will mention later. You listen to this update and feed them into Scylla. Once you do that, you can start writing to Scylla new updates as well. And then you scan all the data, historical data on DynamoDB using the same tool and feed it into Scylla. Once you complete that, at least in theory, the database are in sync, and you can start using ScyllaDB as your primary database. But on practice, since it takes time and you want to validate that everything is okay, you can run, and people do that, both databases at the same time for quite some time, do dual read, doing validation. Only once you are absolutely convinced that everything is okay, you can fade off DynamoDB. By the way, this migration schema is good for any database to any database. I guess the unique part here is the way that we can listen to the DynamoDB stream and feed it to Scylla, which make the migration a little bit easier. The way to do that is with a tool, open source tool called ScyllaDB Migrator. It's built on Spark, and it's have readers from Cassandra, Scylla, and DynamoDB, and writer to Cassandra and Scylla, and maybe to DynamoDB as well if you want to use it. We mostly use it, surprisingly, to migrate to Scylla and not outside of Scylla, but I suspect it's possible. Another advantage of this tool, which is highly performance, highly parallelized, you can add code to the Spark worker and do minor transport or major transformation in the middle. So let's say that you're reading a data, but you don't want to put it as is to Scylla. You want, I don't know, to increment it, decrement it, change the format or what's not. You can do it. The tool is completely open source. And you're more than welcome to use it with other projects or even contribute, I guess, more database to it. And if you want to read more about the tool, there is a good blog post by Ravid that describes this process. He was one of the main contributors to this Spark Migrator. So I put the link here, and if you're interested, you can read more about it. We are almost out of time, so I want to go back to the summary slide I presented at the start. So what I try to do in this presentation is to prove to you ScyllaDB is compatible with DynamoDB, but can run anywhere. In particular, I show how it's run on Scylla Cloud, but I promise you it's run on Docker, GCP, on-prem, everywhere you want. I hope I proved to you that Scylla is less expensive than DynamoDB in many use cases and have a much better P99 latency, but I encourage you to try and test it yourself, maybe with the help of our support team if you have trouble benchmarking. And I show you, not really prove to you, but I show you how you can migrate from Amazon DB to ScyllaDB without downtime. If you want an actual proof, visit the blog post that I mentioned earlier that include all the code. It's also on GitHub, and you are more than welcome to test it. And with that, I want to thank you, and I will be in the chat during this call and after to answer any question you might have.